Product School for giving me this opportunity to have a talk. So I'm Ashok. I'm part of Sam's Club. As you know, Sam's Club is part of Walmart.com, and basically I work on Scan and Go team. So this is like a one-stop shopping solution where you go to the store and you scan an items and then do the checkout on the phone. So that is the work I do, and mostly I'm a tech lead and architect. I mostly come from a technical background, and I have around 15 years of experience in IT. And so why IoT? So I got into IoT like 2 or 3 years back. So one of my friend, he has his own startup. So I'm just doing a freelance for him. So he's a completely hardware guy. So I'm helping out in the cloud and how he can achieve the strategical goal for his company. So that's where I picked an IoT. And most predominantly, I've done implementations on Google Cloud Platform. So that is one of the things which his client wanted to do. So I'm also exploring some of the Azure and AWS. I think the talk would be interesting. Yeah. So what is all about IoT? So the thing is, like, basically things are the one. So Internet of Things, that's what they call. So next is the gateways, the mobile devices, the cloud, and the enterprise. So IoT is not just a software, it's just a complete solution. It's a package solution where you give value to the customers and also bring values for the organization as a whole. So today we are here to talk about the cloud. So cloud part, which is kind of interleaved to IoT. So why cloud? So there is a report saying that in 2020, we'll be having like 20.8 billion devices pumping in kind of zillions of data. So we are trying to tap that opportunity. So why cloud? So if you have a watch, if you take a watch, so you don't have life into it. So until you connect it to the internet. So that is one of the main opportunities which we are tapping now. And what are the other reports say? Like around 4:1 will be the ratio of the devices connected to a single human being. And basically the thing is not a real thing until you get the real value out of it using internet connectivity. So for example, let's take a Bluetooth connected digital stethoscope. So why do we want to invent that? What are the achievements we can do? Basically, if you are a doctor, so we have with the growing population, we just have the ratio of doctors to the patients is reducing. So you create a device called a digital stethoscope, so which can transmit the data towards cloud. So that way you can do remote patients attending. Next is the keyless entry device. As you know, the mobile check-ins. A lot of the hotels have the mobile check-ins wherein they have Bluetooth connected entry to the door. Next is on the thermostat. So these are some of the things which are going to change the day-to-day lives, and basically the cloud plays an important part in connecting all of them to the mobile applications. So next is, as we saw, it is going to change dramatically the way which we the day-to-day life. IoT is already entered. So as of now, you might have seen Alexa or Google Home. You can do voice shopping or whatever things you want to do. So basically, for any IoT, you need monitoring services and a powerful processing of sensory data. So until you tap the data and get a proper insight, you will not have proper value given to the customer. Next is transforming the data to provide productive and cost-effective actions, and then enable business to see where all we can use the technology and how we can tap money from that. So cloud effectively is the brain of IoT. That's what my perspective is. Next. So we have spoken about how cloud and IoT is going to interleave. Let's come to the different deployment models of cloud currently in the industry prevailing. So one is the private cloud, the public cloud, your community cloud, and the hybrid cloud. So let's go each point. So private cloud is basically your on-premise cloud. So for example, some of the bigger organizations, they don't have the flexibility to go to public cloud because of security and concerns about revealing their data outside. So for example, take a case of Walmart. So Walmart, basically, some of the cases we do a public cloud, some of the cases we don't do public cloud because of the sensitivity of the data. So some of them might be related to the pricing information, or what are the different ways of doing our supply chain optimization or the logistics way. These are all customer promises which we provide during the shipping. So those cannot be done in public cloud. So some of the data which is more sensitive to the company, so we keep it in private cloud. So for example, some of the cloud implementations like OpenStack, those are the things I can say. Next is public cloud. So public cloud, we have like a lot of big players. Basically, AWS we have Google Cloud Platform, Azure, IBM. So these are the companies which provide their core IoT solutions. They have opened up their cloud for IoT. Basically, in AWS we have the AWS IoT, in Azure we have IoT Hub, and Google just now they released the beta last year, the Google Core IoT, and just like picking up. And then we have the community cloud. So why we want to go to public cloud? Maybe because of the cost optimization. So some of the clouds, they have like competition. That way we can have like multi-cloud strategy. So we can, based on the needs, we can go for IaaS to Google Compute Engines. And then for, if you want to do some PaaS, platform services, we can go to Azure. Based on the needs, we can go with the different solutions. And then the community cloud. Community cloud is basically a few group of companies having a complete cloud solution. So that is like some companies together, they form their cloud. And hybrid cloud. So hybrid cloud is like mostly catching up because of the nature of the business they are in. So for example, bigger organizations, they might have legacy systems at their backend, like they have like store systems, they have like their e-commerce systems. They want to provide omni-channel experience. In that case, they need to have their backend services or the business objects being exposed outside. So in that case, we go for a hybrid cloud, wherein we have some of the data which needs to be mobile applications, they might reside in the cloud, and then some of the business objects, they might reside in their on-premise cloud. So that way you don't expose the data, as well as you get the benefits of the open cloud too. So Microsoft Azure, the AWS and Google, they already have the direct connection. So they have like a VPN. Google we call the VPN and the backbone networks, so that we can talk to the open cloud during using that. And Azure has their express route, and Amazon has their VPN. That way you have a direct connection, so that you don't go to the open internet and then complete your hubs or different kind of services. So let's see like what are the driving factors which mainly considered for selecting a cloud model. So for any product you want to build, first we need to check about what are the different personas available. So persona is one of the main criteria for a product manager. So we form a fictitious character and the stakeholder. So that way I would distinguish between B2B and a consumer. So from my experience, I've seen like mostly B2B comes into their operational and their facilitators, and B2C is mostly the consumer oriented personas. So for example, in this case, we can take Harry. So he's a store rental operator. So he just does the rental asset management. So he does a manual work of worksheets. So how do you automate him? So what are the different ways you can do? What are the different ways you can provide value using IoT technology? So for him, the challenge would be running the reports, the fine calculation, and overage rents. So that way we can put some devices or kind of optimize that process. So next is the like coming to the customer persona, like Peter. So he's a renter. So he goes into the ski board, he rents ski board normally, and then he goes and put it in a sports basement, but he has to wait for a line. So we can provide mobile check-ins for him. He just like drops it out and then he goes. So that way, that is one of the places where you can use open cloud. And other things is like the need statement. So basically the needs, if you go to IoT, right, like it's not a matured, I would say it's not completely matured for the most organizations. Why? Because like they want to provide more life cycle of the IoT devices. So that is one of the main pain points. So what is the need and what is the revenue on investment? So return on investment. So next is your deployment mode. How do you choose? And most of them go with the cost optimization. They think of a feature which they can do with the existing resources. They don't want to invest more on the new technology stuff. So that is a main challenging point. And next is your analytics and machine learning. So what are the different capabilities each and every cloud provider gives you by their cloud? And next is the security. Security is one of the most important thing which is being overlooked in the cloud industry. And now I think with the growing competition, now all of the cloud Google Cloud providers as well as Amazon, they have their IAM, their own robust PKI systems. Next is your integration capabilities. So that is how you can easily do a lift or shift. So you want to lift your legacy system and put it in cloud, or what are the different managed services they already have, like cache or the different kind of Elasticsearch or their own NoSQL databases. What are the different platforms they provide? And next is your support model. So how do they support? So that is one of the main challenges. Once you enter into the production mode, basically the thing is like they have to be a little transparent on support model and before even implementing. So that is one criteria I would see. Next is the pricing model. So how do they give a discount? So for example, the pricing model works in different way for different clouds. So if you take Google, they have like sustained pricing model. So if you are like for a customer for like 1 or 2 years, your pricing it's totally different. So Amazon gives a different kind of based on the instances, they give the number of instances or reserved instances you buy from them, they give a discount. So Microsoft generally goes with an enterprise license. So if you want like you get more of their products, they give more discounts. So for example, Microsoft, they have their own hub, they have their own databases, they have their own suite of like Office suite. So if you buy more of them, then they give like a lot of discounts for you. So that is a pricing model which we need to look at it. So any questions so far? Yeah, so I have one more video here. Oh man, this is like... So how do you, again need to exit the presentation? Okay. Yeah, it's coming. Yeah. I just closed this. Yeah, this is one of the Creative Commons video. I just found it yesterday. It's about how IoT is like changing.
Revolutionary change. And today, it's changing faster than ever before. Converging new forces of seismic scale are disrupting the landscape, fundamentally reshaping the way we live and work. We call it the age of intelligence. The emerging ecosystem of smart dynamic technologies that are interconnecting every part of our world. It's a profound transition that creates unprecedented opportunities. To seize them demands both vision and the ability to identify, cultivate, and commercialize ideas at every stage of new product development. This is Sketch to Scale, a fully integrated system of capabilities and core technologies which can be applied collectively or adapted to any phase of product creation. It utilizes our unique knowledge, resources, and expertise from a broad range of industries and geographies to anticipate future needs and risks, stay ahead of short innovation cycles, and capitalize on macro trends and emerging technologies. It's our system of operation and your blueprint for success, delivering the innovation, quality, and reliability needed to produce world-class products. During this pivotal moment in history, the greatest achievements will not be built in isolation, but through collaboration, where together we can turn ideas into breakthroughs that enrich our lives and build a better, smarter world for us all.
Okay, as you see in the video, so it's all about collaboration. So for any IoT successful production deployment, you need to have a collaboration starting from the design phase till the production phase. So I would say it's a reach and responsibility for the CIO, the CEO, the CTO, and the product, and the DevOps, and the application engineers. So and also some of the infrastructure development team too. So it's all about collaboration. So let's see what is in on. So on the process of IoT. So basically for any project initiation, we need the business goals to be identified. So this slide, I'm just like mapping on the iteration and what are the main factors and also some of the organizational personas here. So I've captured that in this slide. So first you identify the business goal, then you develop the use case. So it's like kind of an iteration. So once you define a complete IoT use case to be done, you are specific on the problem, then you go out on the roadmap, creating the roadmap. So during the roadmap phase itself, we need to know what kind of cloud strategy you want to do. So basically, as I spoke to you, it's about the cost transparency, the capacity, the cloud migration, the service level management, the security, and the continuous configuration automation. So these are the main factors which you would see during the iteration. So then you launch the IoT pilot or POC. At that stage, we will get like an enough amount of data. So we can pitch in, okay, I'm going to use this particular cloud. And then how do you take it up to the IoT vision and roadmap? So that is when the organizational personas come in, wherein like, okay, I wanted to put this much of resources for data migration, this much of resources for optimizing the cloud. And then here is where the different personas like the OS, the application developers, the security team, the back office, and then the DevOps comes into play. So any questions on this slide? Yeah. So we have spoken about the cloud models and the what are the different factors which decide us to go for a cloud strategy. Let's speak about some of the how a data is being collected from a device and how you do the analysis. So basically any IoT device if you take, so the device part is the real hardware, and then the gateway. The gateway is like in terms of different gateways are there. You can use a Wi-Fi, you can use a Bluetooth, or you can use an SMS channel, or any other ways of like wired connections. So the gateway is the one which talks to the cloud using the different channels. So then it comes to the cloud part. So the cloud part is the one which is going to do us the analysis part for us. And so for any device, if you take the device metadata, so that is associated with the device, and then the state information, the telemetry, and the commands. So this is the kind of data which we look at for any kind of cloud to IoT integration. So then the data flows to the cloud APIs. So cloud APIs can be your any APIs like data on different languages. So it's like the APIs which get the message and then do it to the cloud messaging and then the ML and the data storage. So this can be done asynchronously. So different cloud providers have their own hub. So Microsoft Azure has their Azure hub. In Google Cloud Platform, they have their PubSub. In the AWS, we have the messaging. So these are different types of messagings they have. Or you can write your own customized APIs. So if you have a legacy system which can talk to the different devices, you can still reuse that. So that is a different kind of architectural things you will consider. And next is your ML and the data storage. So what kind of data storage you want to do? So you can go either with your PaaS, like basically with AWS we have the DynamoDB. With Azure you might have the data lake, and for Google Cloud Platform you might have the BigQuery or the Bigtable, or you can go with your own customized NoSQL databases like Cassandra or any other Couchbase or Redis Cache or whatever you want to do the backend. And next is like how do you do the analytics part of it? So analytics is like once you get the data here and then you do the analytics part of it. So analytics can be done by different ways, like different cloud providers have their own analytical capabilities. So Google has their Google Data Studio and Azure also has some of them. So I'm not used much of it, but still you can use your R or you can use your Python or any of the deep learning techniques you can use them. Or you can use TensorFlow also. Like I think TensorFlow is being now supported in Azure as well as like AWS. So coming on to the hosting, scalability, and the security. So the first things you need to consider for hosting is like anywhere access and any device access. So basically, any cloud provider should give a cloud shell which is available for the developers or for the managers to go and access it. So for example, I am a DevOps manager, so I need to go and I want to spin up a new kind of a spin up or want to shut down some of these services. I need to have access to my mobile phone or any kind of service. And then anywhere access and any device access and scale on demand. So for IoT, the scaling is most important part of it. So I would say now most of the cloud providers give the auto scaling capabilities. So basically That is one of the main things, like vertical and horizontal scaling. And next is your enterprise level security. So how they provide the identity and access management, and how they provide network security, the data protection, the data privacy, and the compliance programs. So these are the enterprise level securities.
You're giving this example from whose perspective? Like hosting. So let's say I'm a wearable maker. So is it from the maker of the device or the provider of the cloud for that device?
So basically, if you take that particular product for a wearable, so you are going to publish the data, right? So you are a wearable producer. Okay. So if you want to, so that is up to you to give a complete end-to-end solution, or you can do a build or buy. So you can hire outsource company for a cloud, and you say my scope is like I'll just give a data to you, so you give me a product. So that is the perspective. So
hosting will be done by hosting for whom and by whom?
So hosting, so for example, if you're a large organization, say for example, take Apple in the case. So Apple has their watches, so they have associated apps to it. So they build their own apps, like the health app. So health app uses its own iCloud. But still, so if you take example of Nike, so Nike is also an associated with the app. So they still use the sensor and device hardware from Apple, but they host their own apps. So that's how I see it. Like it's up to you, up to the product manager. So what kind of solution you want to give.
How do you kind of just touched on it, talking about Nike's apps. How do you merge software with existing hardware?
So existing hardware, yeah. So I'll tell you about the different protocols used. So basically it's about like how you, that's what like the gateway. The gateway is the one which talks about that. So either you need to have a Wi-Fi connection or a Bluetooth, or you can use SMS channel. So far from my experience, I've used Wi-Fi, Bluetooth, and SMS. So if or a GPS. So GPS is basically for location tracking, but for talking to outside world, you use either Wi-Fi, Bluetooth, or your modem capabilities. Yeah.
So one more follow-up question. So when you say any device access,
Okay.
are you talking about access to the information for that product, or what access is it?
Yeah. So information access basically. So if you have a device, so you need to talk to the cloud, right? So I need to have identity management for that particular device. So for example, I have an open service exposed in open cloud. So that service can be exposed outside. So you need to have an authentication for that. Like I would show you the public key, the private key. So you can use a transport layer security or HTTPS or the MQTT. MQTT, you have to have an authentication for that. So I generate like JSON web tokens. So the device, when you provision that, you need to have your private key which can talk to the service.
So when you say any device, you mean devices which will talk to the cloud service?
Yes, exactly. Yes. So even Apple, so they provide this watch, they have the sensors. Still, they have to give the permissions for the app developer to go and get the internal hardware out of it. So for example, Fitbit is one of them. So you can write your own app on Android. So Android provided a lot of libraries to pull the health data, but still you have to pay Google to pull the data out of it. So those are like some of the like the licenses, or you have to authorize that app. So it's just basically like you're using Facebook APIs to develop your own app. So that is the contract between the app provider and the hardware provider and the cloud provider. So any other questions? Yeah. So one second. This is kind of oh, yeah, exit. Yeah.
Okay, got it.
Yeah.
Easy does it.
It's coming. Here you go. So this video talks
Internet
about
of
the
Things
security.
describes the ever-growing number of intelligent objects that are being connected to the internet and each other. These systems are infiltrating the heart of our critical infrastructure and are forming the basis of current and future smart services.
Smartphones, tablets, wearable technology, and smart home devices are now being adopted into our everyday lives, and they're starting to appear on enterprise networks. As we continue to embed these interconnected objects and a wider variety of wireless devices infiltrate enterprise infrastructures, the security risks posed by the Internet of Things is becoming more complex and may have serious consequences. Some of these risks are already emerging. For example, many Internet of Things devices in our homes can be connected to a smart hub for easier setup and use. Unfortunately, some of these smart hubs contain serious vulnerabilities that could allow an attacker to walk up to the front door and unlock a smart lock that is connected to a smart hub. For specific smart hub products, this is 100% certain if the attacker successfully gains access to our home's Wi-Fi network. Vulnerabilities in these devices may also allow cyber criminals to search and locate these smart locks while driving around a city, known as war driving. Attackers could then hack into the smart hub to see which devices are attached and even monitor the home through its security cameras. By exploiting these security vulnerabilities, hackers may become uninvited guests to our homes.
Yeah, so this is about the security threats. So there was like a lot of interesting videos which I saw. They were able to hack even the automated cars. So that's like the security. Now it was a kind of a feature in the requirements. Now it's the first and foremost for any IoT product. So let's go to some of the use cases. This is like okay. So these are some of the use cases which the cloud plays an important part. So how many have used the Shopkick app? How many have used? So it's basically an app. If you install, so when you go near Target or any other shops, they have set up some beacons on the stores. So they have a tie-up. So if you go near Target, so you will get a message saying you want to go to you're near Target. If you get the receipt, you'd get like 50 kicks or 100 kicks. So once you get that, next time you get like coupons from them. Like they have most of these e-store, retailers, they have tied it up. So what technology they use is like they use Bluetooth beacons, and then once you detect the phone, they just do targeted content. So this can be used for personalization. So for example, in the holiday times, so they can pump in some of the coupons, or they can even try to detect like how much of line is there. So that is in the retail. And health industry, where I spoke earlier, like it's a real-time location system. So where we have the RTLS trackers on the ambulances, it can track ambulance, or you want to track some of the other important, like say for example, medicinal pallets or something. It's like the reverse logistics, everything we can do. And next is the water management. So this is one of the case study which I saw in like from the city of Houston. So where they have tried to minimize the number of the leaks. Basically, they provided like a lot of sensors at different locations based on the distance, and they had measured like from which distance they were able to pinpoint like where is the leak. So they had to take the leverage of cloud there and hoarding and ads. So their advice is in a company in Bangalore. So their main idea is to have a digital hoardings, which can be controlled outside. So they have a time slot for each and every hoarding, and it can be manipulated with the different companies based on the traffic needs. So for example, they have like a lot of hoardings in Bangalore area near the stadiums where during a cricket match they can target the correct way of ads. And then next on the agriculture, so IoT based smart farming, so that's picking up more now. So you might have seen a lot of companies investing on fresh technologies where they wanted to track the fresh produce, which from the place where you harvest the strawberries to the store. So they want to know the shelf lives of it. So they can track each and every time the date and the timestamp. So that way they can know the real produce time, shelf time. And also they do a lot of irrigation systems based on the IoT sensors. Next is on the energy conservation. So you might have got like the PG reports, like how much you could save, all those stuff. And also they have like sensors on the different meters. So if they are like, they have found any anomalies on that, they can go and do a maintenance. And there is a lift company called Schneider. So they did like a lot of savings on the millions of money on saving on the sensors for the lift maintenance. So they were able to get like send the maintenance people once they sense what happened in the lift. So any questions so far? Yeah. So I just wanted to touch upon how a Google Core IoT works. So I just wanted to show you. Basically, this demo is about how the data flow is from a device and at the different stages of the data. So basically, I can just explain this slide. So a device. So Google Core IoT is a kind of a platform or an API which contains a device registry. So basically, you go there and like register your devices. So any certified partner, or even if you have your own device, you can register with your public key and private key. And once you register to the device, so you are all set for like sending the messages to the cloud. Okay. And then what they have is at the back of it, they have the cloud functions, the cloud pops up, and the cloud data flow. So basically, these are the cloud functions where you don't need to write your own software. You don't need to build your own software. They just provided interfaces there. So what kind of actions you want to take. So, and then in my example, I've shown the cloud pops up. So wherein the pops up is the one which receives a message, and then it gives back a message acknowledgement to the device. And then from the cloud pops up, we can do stream data to the BigQuery or the cloud bigtable or the cloud ML. So I've showcased about the BigQuery. So once you get the data from BigQuery, then you can run your analytics on top of it. So basically, they have the Data Studio. So Data Studio is one of the beta tools which Google has provided, wherein like you can go and plug in any kind of resource. So basically, I have a Firebase analytics tool, or I have Fusion tables. I have the BigQuery table, or you can even have your SQL running. So you have a managed SQL running, or you have a say in Google Drive you have a spreadsheet. So that also you can pull out the data from there. So let me just go through the demo part of it. So any questions on this part?
So what kind of abstractions does IoT Core give over, say, cell processing like RabbitMQ or other field processing?
So basically, the thing is the device management is one other thing. Apart from that, you can still have, so if you don't have a cloud IoT core, you can still host your own services, APIs, and then you can send it directly to the cloud pops up. Or you can host your own RabbitMQ on the compute engine. So only difference between the RabbitMQ and here is like the Google Core IoT is a managed service where it takes care of the device lifecycle. So basically, you register a device and you can go and query which devices, and you can know the telemetry of it. It provides its own unique ID. So I'll just show you the screens. Yes, exactly. Exactly, yes. So you can, what you can do is you can write a cloud pops up or a cloud function. Function can be like a Node.js, basically. But ideal way is like doing in a cloud pops up so that you respond back to the device side. Don't need to wait it. So it will be like asynchronous. So one of the implementation which I did is like I started up with HTTP, and then we slowly transformed to MQTT, which HTTP we started for piloting, and then we wrote like some Java services and Python, and then like as we matured with like more devices coming in after the pilot, then we went on for a more pops up kind of thing, and now we are trying to do some of the analytics part of it. So we had our own SQL running on our compute engines. Let me just go back to the slide. Okay. So this is the IoT core window. So if you see here, right, so that is a device registry. So I just registered 2 devices, and then protocols which is available on MQTT and HTTP. So, and this is the PubSub topic. So this is the PubSub screen. So basically, if you go to Google Cloud Platform, these are the different set of APIs they provide. Like if you want to do an IoT core, and then you have data flow, the PubSub, the BigQuery, and so they provide the Google shell. Let me just connect it. So this Google shell is the one which I was telling you, like anywhere access. So if you are like authorized user, if you have a Gmail ID and you have been given the IAM part of it, so you can go and like open Google shell, and from there you can run the commands. And this is the IAM part of it. So these are the different things which are provided. So IAM, the identity, the quota, and everything. So let me just open up the IAM and admin. So these are the different users. So for example, you want to give them the access to anybody to access your cloud. So you just like go and add what are the new members and then the roles. For the project, you can even be specific to the project level. Like I have an app engine, I have like, I want to give access only to that. So that also you can give. So plus you can manage the resources also here. So basically the firewall rules, these are some of the services which are available. An app engine, the compute and the Kubernetes. So basically the app engine is the one which I was telling, compute engine is the one which is the IaaS, infrastructure as a service. So you get like bare metal boxes depending on the RAM sizes, which you can go and implement yours. And next is the app engine. App engine is like their wrapper. So app engine, you get the configurations completely and you can build your Python or Java on top of it. And Google also have their own managed Cassandra, managed like what are like Elasticsearch. So let me go to the demo part of it. So basically what are the steps is like, first you create a device registry. So that I already created. Once you go into the IoT core, you have to create a device registry. And then you need to generate the signing keys. So basically for the private and the public key. So the public key goes in the cloud and the private key you distribute it among the devices. So the device, when it talks to us, like it has to come with the private key. That is for the MQTT bridge setup. So let me just create a device now. Okay. So let me explain about this particular piece of it. So this is our device. Basically, it's the Node.js code or any other program running your device. Next is your the project ID. So which project you are associated with. Next is your registry ID. So I created the my registry in the topic, and then your device ID, and then the private key field. So this private key file will be residing on the device, and then like what these are some of the other parameters I'm passing, number of messages. So once the messages come, it comes to the topic. So from here I stream it through the data flow, and from here I've created some tables. So this is the table representation of what data we got in. So if you see, this is the new my demo device. So I got like 25 messages, and these are some of the messages I was trying yesterday. So once you get the data here, you can do all the analytics part of it using the data flow. So this is the classification of what messages I got. So basically here I have plotted a pie chart with, so I have only one dimension. So I have plotted the number of messages which came. And then this is one of the public data which I am using. So this is basically to explain the dog counts present in SF based on the street names. And other one is like, you have the geo plots also, where you can region based you can do. So this plot is based on the internet users, current internet users. This is the public data which is, I pulled it from Kaggle. Okay, so let me just go back to the slide. Yeah. So any questions on it? So we talked about like the IoT core, that is a device registry. Next is your the PubSub. So it is up to us like what kind of PubSub you want to use. You can still go with your own messaging systems like RabbitMQ or Kafka, whatever you want to use. And then your data flow, that is the streaming process. Next is your BigQuery, and from there it goes to the data studio. So this is about the complete data flow of like how a particular IoT device talks to the cloud, and how you can pull the analytics out of it. Yeah. So any questions on it?